Alright, this example we're going to graph the linear inequality y is less than 4. So we've got these two ideas here, linear and inequality. We know what linear equations are, and we know what inequalities are. So we're taking these two ideas and we're kind of combining them to create linear inequalities. So if we had the linear equation y equals 4, and we were to graph that, what we'd have here is a straight line where y is 4. So this line here models this equation y equals 4. But we don't have y equals 4, we have y is less than 4. So let's consider the example x is less than 4. When we had this example, we had this number line, we go to where 4 is, we put an open circle because it's less than, not less than or equal to, and then we had a solution arrow covering all of the values that are less than 4. So let's do the same thing, but because it's y and not x, let's go to the y value, 4, which is right here. Got an open circle, and we're looking for y values that are less than 4. So these y values down below 4 are the ones that are less. So all of these y values are a solution. So our solution includes all of these y values that are below 4. Now 4 itself, is 4 itself included? No, it's not. If it was, it would be y is less than or equal to 4. But it's not y or less than. It's not y is less than or equal to 4. So 4 itself is not included. So instead of having an open dot, because we're graphing a line, we need to figure out how to represent that based on our line. Well, consider the fact that y equals 4 is a solid line, right? Just like when x was less than or equal to 4, it was a closed dot. So a closed dot is the same thing as a solid line. An open dot is the same thing as dun, 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 a dashed line. So if we have a less than or just a greater than with no equal to, that line that we're drawing is going to be dashed. Graph the inequality y is greater than or equal to negative 2x plus 1. So the first thing I'm going to do, so I guess my first step, is to graph this like an equation. So graph the equation. If this was an equation, it would be y equals negative 2x plus 1. Our slope here would be negative 2, and our y-intercept would be 1. I'm going to graph the y-intercept at 1, and then our slope is negative 2, so we'd go down 2 and over 1, down 2 over 1. If I want to graph these points up here, I go up 2 to the left 1, up 2 to the left 1, right? So now we've got enough points so we can draw our line straight through the points. So we've graphed the equation, but we don't have an equation, we've got an inequality. So what's our second step? Our second step is to figure out the line. Is the line solid or dashed? Well, remember, solid lines are the same thing as dots that are closed. And how do we know if a dot should be closed or a line should be solid? Because it's an equal to. So if it's an equal to, like this one is, because it's got this little line right here, then we know that the line needs to be solid. So we can leave this as a solid line. Second step we've already completed. So the third step, right? So the final step is the solution area. So what are our solutions? For example, is the coordinate point -5, -4 a solution? Or is the coordinate point 5, 5 a solution? So we've got below the line or above the line, below the line or above. So are we looking for below or above? So consider this for a second, below or above the line. Well, we can do this two different ways. First, I'll do the more complicated way. The more complicated way would be to take this coordinate point, -5 for x and -4 for y, and plug it in for x and y, and then see if it comes back true. So let's go ahead and try that out real quick. So -4 for y is less than or greater than or equal to -2 times -5 for x plus 1. Simplify, we get 10 plus 1. We get 11 is less than or equal to negative 4. This is not true. Not true. Let's look at this coordinate point up here. 5, 5. So we got 5 for y is greater than or equal to negative 2 times 5 for x plus 1. Negative 2 times 5 is negative 10 plus 1. Negative 10 plus 1 is negative 9. Negative 9 is less than or equal to 5, or 5 is greater than or equal to negative 9. This is true, so we know that this is a solution. So we know that we're shading above the line. But a much, much easier way would be to look at the sign and the y. We know that we want y values that are less than 1 or y values that are greater than 1. Well, the sign is eating the y, so we want y values that are greater than. So these y values up here. Write an inequality for the linear inequality. So we have a linear inequality that's been graphed, and what we're doing is we're writing the inequality for it. So our first step is to create the equation. We're not creating inequalities first. We're not going to create an equation, or our answer is not going to be an equation, it's going to be an inequality, but the easiest thing to do is create an equation first, and we know that equations and slope-intercept are mx plus b, where m is our slope and b is our y-intercept. So we look at the graph, we see the lines crossing at negative 3, so we know b is negative 3, and we need to choose another point to calculate the slope. Let's choose this point right here. Now we need to calculate the rise over the run. So it rises once, and it runs twice. So our equation here is y equals 1/2 x minus 3. Our second step is to figure out the sign. The first thing we want to do is figure out, is it a greater than or a less than? The way what we're going to do to figure this out is look at the b value. This is our y-intercept. So we look at the b value at negative 3. Look at the b value at negative 3. Is the graph shaded above or below? Well, it's clearly shaded above, and these y values are greater than our y-intercept or our b value. So the b value is greater than, so that is the same thing as y value, or the y is greater than. Our third step is to figure out, is it an equal to or no? Well, if it's an equal to, we knew it's a solid line. If it's a not equal to, it's a dashed line. We've got a solid line, so it's, yes, it is an equal to, so let's put it all together. Y is greater than or equal to 1/2 x minus 3. So y equals mx plus b. We know that b is negative 3. We know that the rise over the run is, let's see, it goes perfectly through this one right here. 1, 2, 3, 4, 4. And it runs once. So we know that the rise over the run is 4 over 1, which is the same thing as 4. And our sign, let's see, we go to the b value, the line is shaded below, these b values or these y values are less than, so we know that y is less than 4x minus 3. And is it equal to or not? It's a dashed, so it's not included, so we're going to leave it just as y is less than.